Good morning, everyone. First of all, I would like to welcome you and thank you to all of you for being here, sharing your time in this webinar organized by SOILveR. We have prepared it with a great enthusiasm, so we hope that you get your expectations. So, first of all, next slide, please. First of all, I would like to present in brief what SOILveR is. As you can see in the slide, it's a self-financed platform. That means that we all participants contribute economically to the activities. And our main goal is to develop and exchange knowledge on soil and land management. We are completely we agree that the best way to advance in this topic is to work together, work together with experts, policymakers, and other stakeholders, but also with people from other countries. So that's our mission and our motivation. Currently, the members of this group are this you can see on the slide. Adem from France, the Ministry of Infrastructure and Water Management from the Netherlands, SPAC and SPW from Wallonia, the Swedish Geotechnical Institute from Sweden, of course, and IOVE, the last member getting into SOILveR, IOVE. This is the public agency for environmental policy in the Basque country. Next slide, please. I'm not going to get into detail of the activities we have been working on since 2018. You can see there the many things we have been doing. I will focus only in the last activities and mainly in the soil health webinars we are organizing the past year and this year. As you can see, it's we have prepared a series of webinars focused on soil health at different scales. There was a first webinar last year on November the 5th, and there will be another 4 webinars. Today is the day for the first one. Next slide, please. But there will be 3 other webinars along 2025. You can see that the second one will focus on recycling brownfields in April. The next one topic will be contaminated sites management in September. And the last one, a bit different one, would focus on technosols in September. Anyway, if you want to get more information, you can visit our web page, and you can also follow us on LinkedIn in the links you have there on the slide. What we can get from this, next slide, please. What we can get from these webinars is something related, of course, to our goals, to the goals of SOILveR. We would like to share methodologies for soil health assessment, and we would like to get knowledge of how to integrate soil protection criteria into urban soil management. We will also need to identify gaps in knowledge so that we can get so we can go on working on collaborating among us and other people. Next slide, please. Next one, please. Perhaps you can read. You cannot read this slide properly because it's a bit small. But I wanted to show you our reflections when preparing this topic. For the webinar, we wanted to answer some questions about how to ensure healthy soils in both urban and rural areas, which instruments we could use, how to get to the net land take goal. And for this, there are many questions to be answered. We thought that the audience should be with people from public authorities, public policymakers, experts, spatial planners, and other kind of people. And we also wanted to have an interactive session, as interactive as possible, taking into time, taking into, oh, I've forgotten the word.
Accounts.
Taking into account, yes, thank you, Esther, that the time we have for the webinar. Next slide, please. With these ideas, we have prepared the agenda. You already know, but we will give you some information, a brief information about how it's going to go on this webinar. Next slide, please. There will be 3 blocks. The first block will be devoted to a general view of the topic. The second one, some methodologies to assess soil health in practice will be presented, and the last one will be the presentation of 3 cases of soil management. We have tried to have in 3 blocks presentations both in rural and in urban areas. For every block, you will have 5 minutes time to ask questions just after the presentation. It will be this way in 3 blocks, but in case you don't, your question has not been answered, you can pose it again at the end of the session during the panel discussion, where all the experts will be there to answer your questions, your suggestions, or anything you can comment on the topic. And finally, next slide, please. Oh, there is not another one? Previous one? Oh, that's it. Yeah, we would like to invite you to participate with your ideas, your knowledge, your everything in a Miro board we have prepared for this topic. I suppose most of you know how to use it. If you don't worry. It's a very friendly tool. So the question is only to take these post-its. You can see there, and you can take one, stick it where you want, and write your ideas. We are willing to get your application, so please use it. It will be open not only during the webinar, it will be open during the whole year, and to get ideas for all the webinars. So please use it. We will be very grateful for it. So I think it's everything from my part, and then I don't know if I have to give the floor to Francie Hoyer-Meyer, or Esther, do you want to say something in the middle?
No, that's good. Let's
okay.
dig into the first one. Thank you very much. My name is Frans Hoijmeijer and I work at Technical University in Delft. And I'm part of the SPADES project, which is a Horizon Europe project with many partners, 17 partners. I think also already a group of partners that is has been Anna. I know. Anna, yes, thank you. Partners that I think already been working on soil integration in space for the past 15 years. The project SPADE, Spatial Planning and Design with Soil, is the result of Europe now also putting out regulation like the soil monitor to enhance the quality of soil health in the European countries. Can you go to the next slide, Inge? Yeah. So this is the first result of the preparation of the project we just started in September, where we had to bring together the perspective from soil scientists, which is of course very much aimed at quality, but also the perspective of the spatial planning field, which looks at performance of space. In the end, we plan and design cities for a good performance where people can live healthy and happy. So you can see here the acknowledgement of different spatial typologies in rural, peri-urban, and urban areas, and the three aspects of soil quality, soil quantity, and soil performance, where the quantity is about also the no net land take of the European Council, and the soil performance is very much connecting planners to challenges of climate change and making climate buffering, but also environmental crisis. Next slide, alsjeblieft. So the planning system is something that is very fluid and very changes every day, and is a collaboration between laws, policies, regulations, and institutions aimed at increasing spatial quality. You can see that the system is connecting different scales, so from the local to the national to the European scale. And now in our project, we are really trying to see how the European scale can be influenced by the local scale and vice versa. That's why I'm also very happy with this session, which is more general, with our speakers that are showing how you need really projects, so design projects, to be able to scale up to larger, say, higher government planning conditions, because we also need these planning conditions to give the right boundaries and the right, say, starting point for urban design projects. What is interesting is that, for planning, there is very little European policy. There are some that are very important, like the environmental impact assessment. It's also basically the only instrument to really check spatial quality and its environmental impact. And also something like the Natura 2000 is an example of course, impacting spatial planning. Next slide, please. So one of the pilots of our project is the Green Heart in the Netherlands, and this is an example of a no net land take, historical no net land take principle. So it is a national planning policy to keep the heart green and to have all our cities around this green heart, which is called a Randstad, sort of border city. And this is, of course, really also making sure that there is open soil in close vicinity of all these urban cities. Next slide, please. So the planning conditions are not only steering on land use, and this is then a lower scale. So this is more a local scale, a result of a policy. This is Amsterdam, which you can call a finger city, where they decided to have green wedges entering the city, again, to have a close relationship between open and closed soil, where, of course, the open soil has the performance of natural areas and recreation and health. And, of course, the closed soil is for the other urban functions. Next slide. But importantly also is that it is not just land use that comes, and that's why our project is called Spatial Planning and Design, because especially in the design of cities, there soil is very important, and especially the quality and the performance. So as you can see is in an urban design phase of an urban area, the decision is made of how many houses need to be there, what is their footprint, and what is the relation between open and closed. And everybody knows the post-war areas where there's a lot of green, so there's a lot of soil, but maybe there the quality isn't not as good because there's maybe sand added or other things. So the control of urban design on this smaller scale is quite high in working with soil. And this is something that a project really wants to have, point the attention to and also be aware. And I think this morning we already have quite some nice examples in the cases on how to do this. And this is what needs to be done more also to be able to scale it up to a policy level. Next slide, please. And this is an example of also a design process. It's not just a nice image in the end. And this is an example of how, with different perspectives, you can design a urban program in a location in different ways. Next slide, please. And then eventually this design is translated into a land use plan. So when you see a land use plan, it's not something that is just drawn. There's a whole design process weighing all interests in an area, and now also of soil in this case, into a new future. I think that this is my last slide, and also shouldn't be talking too much because we have three very nice speakers that, is this the last slide? Oh, I forgot about what I put in. I think the next slide, yes. So this is our team and the funding. So we have in this session three very nice examples of this relationship also between design and policy. They all three have 10 minutes, which is each 10 minutes, which is of course it's a challenge, but I'll introduce them and I'll try to wave somehow to you, Alain, Antoine and Brieux for time. So our first speaker is Professor Dr. Antoine Viaud from the TU Delft. He's an architect, doctor in urbanism, and experienced with working in soil-inclusive spatial planning and design and research. He's a professor for climate-oriented urban design and urban systems in Berlin, and his presentation is about soil-based urban design for climate-resilient and inclusive cities. Please, Antoine, take the floor.
Hi, everybody. Do you see me?
Can I see you? Yes,
we see you.
Then I'm going to share my screen, make sure that everything is okay, and then I will start. So I share my screen, and then I share this, and now you should be seeing my slides in full screen mode.
Excellent, yes.
Yeah. So hi, everybody. It's a real pleasure for me to take part into this this webinar. Thank you for SOILveR for organizing, and I'm very happy to take this opportunity to also engage discussion with Franche and the other presenters. So I will start this presentation on soil-based urban design for climate resilient and inclusive cities by saying a few words on who we are. So I am professor for climate-oriented urban design and urban systems, and I am leading the chair of transitioning urban ecosystems, Q. And our endeavor for the next coming years is really to set the framework for soil-based urban design, planning, and maintenance. And so we somehow are committed to develop urban design strategies for urban soil preservation and regeneration through the ecological transition and sustainable requalification of metropolitan areas. We work especially in Europe so far, and we work in the first place on a territorial scale. So I am giving you an example. I will come back to this example a bit later. We also develop those strategies on the urban scale, so the scale of urban development or redevelopment project, the scale of a neighborhood. And we also work at the closer scale, since we also teach a lot of architects, the closer scale of spatial and architectural interventions. Soil-based urban design also encompasses a wide range of societal engagements that aims at, in particular, at raising awareness of urban soils' importance among different communities, in particular inhabitants. We do this we ground our design approach into in-depth interdisciplinary and transdisciplinary interactions, in particular with the earth and life sciences. And of course, for us, soil-based urban design planning and maintenance is developed within a living lab framework in close interactions with local actors and stakeholders. So I'd like to somehow introduce design strategies by grounding them into a few scientific findings we somehow elaborated through various research and design projects. So first, this started with my own doctoral research a few years ago, which aimed at describing urbanization process, the process of urbanization as a process of soil transformation or even soil creation, what is called anthropogenesis. And I will not explain my whole thesis in 10 minutes, but I would like to comment these maps that I produce in this framework. These maps represent the various trajectories of soil transformation that affect soils in the region of West Lausanne, in the French-speaking part of Switzerland. And I did this map for the beginning of the 19th century and for the contemporary period. And somehow, on the right, you have the contemporary period, and this is a sort of random portrait of what I would call the contemporary city, something that is in between the very dense old city centers and the rural area. And in this map, I like to comment the map, and also you can see next to the map there is a diagram that represents the proportions of each of the surface that is affected by the different soil trajectories. And what you see is that a third of this territory is still in forests in green or in agricultural uses in yellow, which means that somehow a third of the contemporary metropolis and their urban soils are made by pseudo-natural or agricultural soils. Then another third is in blue, and it represents all the soils that are affected by earth movement, cut and fill. So basically soils that have been reworked by humans, that are not in agricultural productive uses, and that are basically what goes along with the built environment, the open soils, functional soils next to our buildings. This is basically what we call a garden, green spaces. And then the last third of this territory is really the soil that is artificialized. And in this, we have only 1/3 of this third that is really the built footprint. That is not so interesting for me because we should keep this built footprint. It's embedded gray energy, and it has to be just improved and densified. But then a 2/3 of this third, what I represented in red, is sealed surfaces dedicated mostly to transportation. And we can see that for 1 meter square that is built up, we have 2 meters square that is sealed. This is not efficient. This is too much. And here we have a room for improvement. So we have sealed surfaces, we have the green spaces around our buildings that have a very variable quality in blue, and then we have the pseudo-natural soils. And this is a portrait of urban soils in the contemporary city. Another research that I developed more recently, mostly for the Ministry of Environment in Switzerland and for the canton of Vaud, is about the capacity of urban soil to sequestrate organic carbon and therefore to contribute to climate change mitigation. The aim of this project was, one, to assess the carbon stock in urban soils of city of Lausanne and Zurich. Then to understand the distribution of this carbon and to understand what are the drivers of urban carbon sequestration in urban soil, to understand the agency of urban planning, design, and maintenance policies on carbon sequestration in urban soil, and then to come up with improvement measures through various guidelines. So I won't comment everything. What we did is we sampled about 300 soils in Lausanne and Zurich according to different vegetation cover to assess the carbon stock and to understand why they have more or less carbon. And this is some results. I will synthesize saying that first, carbon sequestration in urban soils work as in the agronomic environment is depending on the geomorphology. but it's very difficult to assess because there is a lot of variety in urban soils. Second, we had the hypothesis that, for example, urban forests would sequestrate more carbon than the very poor lawn that you have next to your building. It's actually not very true. It's very variable among each type of green space, and all of them contain a lot of carbon, and way more than their equivalent in the traditional intensive agriculture nearby. So urban soils, at least from the carbon point of view, are very functional. They have a value, and we need to preserve them and redevelop them. And also, the last finding is that our maintenance practices, have an impact. There are more carbon in privately maintained soil than in public soils. There is more carbon in the soils that are less compacted. So these are challenges because it's very difficult to have an impact on private urban soils. And then, so now, when it comes to policy, what can we do with these findings? And we are in a situation where there is a double binding between some law trends, in particular at the European level, the no-net land take strategy that says, okay, we need to preserve agriculture and natural environment, so cities needs to develop on themselves, they need to become denser, and we need to urbanize the city in the city. We need to densify the city or to have a compact built environment. Compaction for soil scientists is a bit problematic. And we have another trend of law which says, okay, we need to make city resilient against climate change. So we need more environmental functions within the city, which means we need more functional soils within the city. So we cannot go to urban sprawl, but we cannot go neither to over-densifications. And here, what do we do with this conflict of interest regarding urban soils? And this is what I tried. So I tried to synthesize the various range of possibility into this sort of diagram, which represents a sort of compass with two different axes in order to guide our action. On one side, the horizontal axis of this compass, we have soil as a resource. We look at soil functions and the services they provide. The variable is soil quality. And we can improve soil quality by the way we manage soil. This is basically what we do in agriculture usually, improving the soils and their functions by maintaining them properly. We talk about regenerative agriculture today. Can we have regenerative urbanism today? This is one axis on soil resource. Then we have the soil stock or the soil capital. In here, we look not only at quality, but at quantity. And this is something that doesn't not apply to agriculture. This applies to urban context because we have a lot of sealed, artificialized soil in urban context, and we can regenerate them. And then we have more soil and therefore more soil functions. And this is specific to the urban environment. It deals with land use change and not only as soil change. I would like to show you a few examples on how this applies. This is a project that I developed with my colleague Yannick Poya from the TerraSol soil consulting firm in Switzerland, also with a colleague from ETH Zurich. And we did this European project. Maybe some urbanists in the room know what is European, and it's a competition for ideas. And we try to develop this sort of a manifesto of what could be soil design in this project for the neighborhood of Carouge-Fontenette in the suburb of Geneva. And here we started with a soil section throughout the neighborhood and to understand the potential environmental performances of those soils. And then the idea was to really regenerate the neighborhood by remodeling completely the topography and the substrate of the neighborhood. So basically proposing new urban soil for this neighborhood. But new urban soils doesn't mean just a topography and a substrate. It's also proposing absolutely new uses and spaces, so therefore new urban morphologies and way of life in this neighborhood. And basically, as a manifesto, we imagine that soil correspond to three main challenges. Urban soils as resource deposit. Whatever we do, it's going to end up producing soils. And somehow we can, urban soils can be regenerated because they are mostly sealed now and artificialized, and so we can create new soils from our own metabolism. Soil and resource deposit. Then we have
I need you to ask you to start the closing.
wrapping up. Soils as a garden. We live among functional soils, and we need to understand that. And then the last one is soils as ecological infrastructure, providing care and inclusive ecological infrastructure. I will wrap this up by showing how this can be a process in urban design by showing three typical situations: cultivated soil in the environment, sealed soil, and built-up soil. We need to preserve the functioning existing soils because they have their own carbon stock, and this should be preserved. We need to improve urban morphology to densify without consuming too much soil in the city, and then we need to deseal artificialized soils. Then based on this, we can recreate new soils by implementing circular metabolism of construction and green wastes, and so recreate new soils that will sequestrate more carbon and provide other environmental function. And then by diversifying uses and vegetal covers in the city, we can gradually, in the next centuries, sequestrate more carbon and provide more ecosystem services. And then in 1 minute, we developed for Lausanne 3 different scenarios, how starting the city from the voids, including soils to preserve and soils to regenerate, can create a structure, a porous structure in the city. So we work on voids, we work on porosity rather than in compaction, in order to drive an appropriate densification. This leads to a new public space typology that are based on desealing. A second scenario is about metabolism and closed loops in waste and resource management. This can lead to develop soil farms, soil nursery, soil laboratory as new ephemeral and transitory urban landscapes that are multifunctional and that are places in which people can engage with the topic of soil and also urban ecology. And then the last scenario, this is my last slide, how this green network of open functional soil in the city can become a new backbone for urban development, and in which we can think urban spaces and in particular public spaces are as genuine ecological habitats. And so start from a paradigm that is asphalt to a paradigm that is urban space as vegetal and porous. Thank you very much. I hope I didn't took too much time. And I leave the floor back to you, Franche.
Thank you, Antoine. No, that was wonderful. And it is, of course, torture to be forced to explain complex projects in only 10 minutes. The good thing is that the presentation will be shared. So you can take a look at that. And then, of course, we always have our Google friends to get you towards more details. So thank you again. Alain, maybe you can start up your presentation for our next speaker. So Professor Alain Malherbe from the University of Louvain. He comes from the architecture and arts field and has a PhD on territorial development and more particularly on cross-border metropolitan territories. And of course, there the natural system is crossing per definition. He's coordinating several research projects on urban biodiversity, also social inclusion and homelessness and cross-border metropolitan development. And his contribution is named Some Land Use Planning Mechanisms for Safeguarding the Health of Urban Soils in Wallonia and Brussels. Please, Alain, take the floor.
Thank you, Franche. Good morning, everybody. I begin my presentation now. I share my screen. Okay. It's all right for you?
Yes, perfect.
Okay. So I propose to you to present my issue of the urban fabric. I'm developing the interdisciplinary research about the urban soil, the existing urban soil in the urban fabric. So the diagram, the very famous diagram of the Food and Agriculture Organization, show the function of soil based on the reality of rural areas. So I think it's very important to adapt maybe this diagram about the urban soil. So in this diagram, do you see the different organization of the ecosystem function? This diagram from the Natural Capital and Ecosystem report from the European Environment Agency, and the diagram show the knowledge of soil that's so far focused on the rural area and of the natural capital, and there are two entrance is the stock with a resource. The natural capital from the soil is a resource, like Antoine said, and the flow with the goods and services. In this part of the diagram, there are also the stakeholders recognize the value of the soil through the prism in terms of the contribution to well-being and the utilitarian value here. So I think for me, I prefer the term use value to utilitarian value, but this issue is widely debated in the civil society and the academic world for the moment. So this is another diagram, summarizes the human project design process. So with the first step, there are the historic soil anthropization. After that, we will need the environmental analysis data and to have the land combing available again, like activities abandoned in the brownfield and the urban renewal. And I would like to talk to you about the territorial governance through planning, because there with the non-net take, the suburban residents build transfer to the urban fabric with the density, and the density is of course a good way to meet the no-net land take. And after that, we have the urban design. So the issue is the localization and design of urban project to preserve and regenerate the health of urban soils, with each specificity of urban soils. Two sectors of soil health governance is important: the environment, of course, and the land use planning and urban design. It's very important to these two sectors. They will be have interaction. Here you have an example for the Wallonia-Namur city. This slide shows the soil, the map of the main types of soil. There are in this map, the artificial soils is not mapping. So it's interesting because we have no knowledge about the soil, the urban soil, the artificial urban soil. There are another kind of knowledge on the urban soil is the soil quality, with the soil quality index map from Brussels by Environnement Brussels. And this map shows us that different point with the different quality index, and this one is interesting knowledge to understand what the soil quality is. There are maybe 4 indicators about the environmental assessment on soil. I think it's interesting to have the saving rate. They are in Brussels region. There are another one is the open ground coefficient. Like this is the schema diagram from the strategy territorial development plan from Wallonia with different ratio, and is this politics. We would like to have the Wallonia would like to have an open ground coefficient of 30% to 70% open ground space, in centralities to rural areas. The other indicators is the biotope coefficient per surface area, CBS+, and other tools developed by the Brussels environment, and the soil quality index. So the knowledge of human soil is still, I think, incomplete and fragmentary and need to be consolidated and more completely. And knowledge of soil health is relevant at the parcel scale. And I show you now land use planning governance tool, like the plant sector in the Wallonia region. There are a lot of, there are three parts of governance of spatial planning, three main parts. The strategic part focuses on what we want to do, the regulatory part on what we can do, and the operational part provides the resource for what we are going to do. I present to you the regulatory part with the plant sector, and after that, the Plan Régional d'Affectation des Sols in Brussels. So the Wallonian Plan presents large functional zones, housings, economics, community facility, agricultural zone, and so on. But the Brussels plan present in more precise because it covers a smaller territory and highly urbanized area. The road and public space, for example, are represented on the Brussels plan. So there are another tools. The tool is the Namur Municipal Development Plan, the Schéma de Développement Communal in French. The level of detail is found, which develops territorial strategy at municipal scale, and the strategy applied the objectives of the Wallon Strategic Territorial Development Plan. And this plan specifies the Wallon sector plan, prioritize the land reserve to be implemented, and guide potential revision of the regional sector plan. So when use these tools, they are not part of the soil issue. So it's important to integrate it. And the land use planning governance tool need to input from the environmental sector before environmental impact studies are carried out. In-depth knowledge of soil ecosystem services should contribute to project design and be better integrated in the impact study. It's very important, I think. And the allocation of function by zone, housing, economic, green space, and so on. In the land allocation map, with the period in 1917 and 1918, period was based particularly on the typology of soil, the map to show you before, and did not take into account soil that had already been artificiated. Sorry. There are three examples now by Brussels and Wallonia region with the project maybe sorry.
Alain, you have 2 more minutes, okay?
2 minutes, okay. I have quickly now to finish. So there are two projects in Namur city center. One is the pedestrian of the street of the fair, with the vegetalization and the unsailing soil, and the same in the real estate project with the parking slabs to take in vegetalization and selling too. The other tools is the Brussels Master Development Plan. The PAD is the North Territory near the center historic from Brussels, the Pentagone, and they have this project is a governance tool of project, the preoccupation of the urban agriculture here, and the project to unsiling the concrete slabs here, and to regenerate soils here, and to, of course, vegetalization, the concrete slabs. So I would like to put your attention about two different projects outside Wallonia and Brussels. This Parc Madrid Rio in Madrid. This park is interesting for me because it don't take account the underground soil because there are highway in the tunnel and under highway in the tunnel there is a park, and for the filtration and percolation of water is not very good, I think. And this park have also need to have the water regulation is particularly in terms of the maintenance of the vegetation is very big questions. So to finish my presentation, I propose to you to see the Parc de la Plaine du Loup in Lausanne. And this park is interesting because it shows you the importance of the inclusive city by the soil. And to conclude it, I think the knowledge obtained from experience carried out during the design and implementation of urban project will contribute to the adaptation of the existing governance tool and the development of new methods aiming at preserving and rehabilitating, regenerating the ecosystem services produced by urban soil. I think in a holistic and focused approach, in the both approach, the systemic approach and the focused approach. And the urban soils is very important. So for the social, community, economic, environmental heritage, and the function of soils must be completed by this topic. Thank you very much for your attention.
Merci, Alain. Very well. Very nice presentation with very nice examples, I think, again, to research further maybe for the participants. I suggest you put your questions in the chat and maybe Alain and Antoine can also already answer them because I'm afraid that we're losing our 5 minutes of questions at the end of this block. I would like to invite the last speaker, Brieux Hardy, to share his presentation. And Brieux is a senior researcher at the University of Louvain and a soil scientist experienced with remote sensing and image processing tools and an expert in data analysis. And his presentation will be about soil health measurement in rural areas, gaps, needs, challenges, and opportunities. Please, Brieux, take the floor. We're now showing your last slide, so you have to go back to the beginning. And we don't hear you, so I'm not sure if you're speaking.
Okay, can you hear me now?
Yes, we can hear you now.
And do you see my screen?
Well, we see your private screen,
okay.
so you have to turn it around somehow.
Okay, I'll try again then.
Yeah, maybe there. Yeah, I'm very bad in these things, so I can't.
You can change the parameters, les paramètres d'affichage.
I'll try again. Tell me if it works better. Is it okay now? Or
No, you're still sharing your notes.
Les paramètres d'affichage, il y a deux types d'affichage. Si vous cliquez au-dessus.
Top of the
Le
screen.
menu tout au-dessus.
To the left.
Do you mean in Zoom or on my presentation?
C'est dans la barre, c'est le menu tout au-dessus. Il y a affiché la barre de tâches, paramètres d'affichage. Il faudrait cliquer sur la petite flèche.
Paramètres d'affichage. I don't see that.
It's on the top of your screen.
Yes, but I cannot see it.
Yeah, because you have to go to this.
Parameters.
I think it is written option d'affichage, Brieux.
Where do you see it?
It's in the Zoom.
In the Zoom window, just beside the green band.
Do you have two screens, Brio?
Okay.
You have to go to the other screen where we are seeing your Zoom sharing.
I'm sorry for this. It was working during the trials. So, okay. And this, if I change.
Yes, perfect.
That's fine.
Yes,
okay.
perfect.
Sorry for this.
Let's go.
Okay, let's go now. So thank you, Francia, to introduce myself and to give me the floor today. So I will put the focus of my thought on the issues of soil management and land planning related to soil health measurements in rural areas. And as Alain said, the challenges are quite different from that in urban area because we don't look at the same soil function. So by rural areas, I mean agricultural soils, but also forest soils used for biomass production. So for the context, so we have an ongoing project nicknamed IQSW for Index of Soil Quality in Wallonia. So the goal of this project is to develop a tool to measure soil quality in Wallonia. The objective of the project is twofold. So first, we want to develop a tool for citizens that should be applicable to garden mainly and parks. And this tool should rely on simple field tests and observation and should guide citizens towards practical recommendations of soil management. The overall goal of this tool is to raise public awareness on the importance of soils for human society. The second goal is to develop a tool for professionals that must cover every soil use. And this tool will rely on measurable soil properties chosen to score soil functions or soil ecosystem services. The ultimate goal of this tool is to define the right use for the right soil in land planning and to provide guidelines for soil management. So to meet the ambitious goal of this project, we can rely on a multidisciplinary team. So the project is led by 3 institutions with complementary skills. So we have one university, the University of Louvain-la-Neuve. We have Ariès Consultant, which is a small company leading soil studies. And then we have the Walloon Agricultural Research Center. And this includes actually 3 project leaders, 2 engineers, 1 computer scientist, because we are developing an IT tool, an expert in geomatics and modeling, an expert for environmental impact studies, and of course, several soil specialists with complementary expertise. And we also work with communication experts. And this is well necessary to meet the challenge of soil multidisciplinarity. So in this project, we also make our best to involve stakeholders in a participatory process. So this started on the 11th of April with a kickoff event during which we collected the needs for soil health measurement tools and the fears about the consequences of the availability of such a tool. We then organized topical workshops on urban soils, agricultural soils, and forest and natural soils to brainstorm about specific needs, soil ecosystem services expected, and most relevant soil indicators to assess soil quality for each soil use. We collected a proposition of test sites to validate the prototype version of the index, and we plan to organize other workshops to validate our methodology after the testing phase. So these exchanges with stakeholders have contributed to document the elements that I will share with you today, specific to rural areas. So, okay, let's zoom on the issues of soil management and land planning related to soil health measurements in rural areas. And first, let's focus on agricultural land. So, first specificity of agricultural land is that most of them occupy the least restrictive soils in terms of slope, stone load, soil depth, water holding capacity, with few exceptions like vineyards. Second specificity is that soil management is generally very intensive and frequent on these soils and aims to bring the soil to an optimum state for biomass production by application of fertilizers, amendments, and even pesticides by mechanical interventions such as drainage and tillage. So about the threats, agricultural soils face multiple threats of degradation like soil loss, soil organic matter loss, biodiversity loss, pollutions, excess of nutrients, compaction. And overall, a main issue of land planning is that agricultural soils are particularly vulnerable to land take because they are generally accessible, flat, and free of blocking vegetation. So now if we put the focus on woodlands, in contrast to agricultural lands, in Wallonia, forest is grown mainly on soils having limiting factors for agricultural production. This means steep slopes, high sand content, high stone loads, poorly drained soils, etc. In terms of land management, the logic is generally to adapt the tree species to the terroir according to its water and nutrient requirements. So it's an opposite paradigm compared to agricultural soils. And soil management is generally less frequent because harvests occur less frequently, but field operations are very destructive. So soil compaction is the main issue in production forests. And another long-term issue is soil acidification. I mean by acidification, the unbalanced nutrient exports, because nutrient outputs are generally not compensated by inputs. So accordingly, in forest production, forest specific needs exist to improve the management of forest soils, such as the availability of intervention planning tools based on weather conditions and soil bearing capacity, effective approach to measure the compaction at different scales, effective rules for forest partitioning for harvest, and the development of alternatives to conventional skidding like horse skidding or wiring. So what are the main expectations and opportunities standing behind the measurement of soil quality in rural areas? First, is to take into account soil ecosystem services that have no monetary value, like water regulation, biodiversity conservation, climate regulation, together with monetary ecosystem services such as biomass production and physical support. Then the main challenge in land planning is certainly to better protect agricultural and forest soils against land take, measuring soil health beyond pollution, because at the moment we have a Walloon soil decree that regulates the soil pollution. So measuring soil health beyond pollution may help safeguarding healthy soils from land take. And currently in Wallonia, we kind of do the contrary, because the Walloon soil decree makes it more difficult to reuse artificialized area than artificializing healthy soils. And so if we want to meet the zero net land take objective by 2050, we need to shift the paradigm in soil management on this point.
2 more minutes.
I'm almost done, so it should be fine. So another opportunity related to the development of a soil quality measurement index is to better manage excavated soil beyond the pollution criteria, and this also applies to the creation of neosoils. So provide guidelines and threshold or target values of soil quality when we create a new soil from sediments, from landfills, etc. And overall, a better soil knowledge may help improving soil management against external pressure, such as the increasing occurrence of extreme climatic events and new pests that come with the climate change. And in particular, for rural areas, I believe that an access to quantitative soil physical and biological indicators is currently missing and could improve the situation. That is all I wanted to share with you today. So thank you for your attention. If you are interested in our IQS3 project, there is the link to our website. And also this little spring tale, just to remind you that soils are full of life and they contain about 50% of the entire terrestrial biodiversity. And we only know a small fraction of it, so let's safeguard our healthy soil. Thank you.
Thank you very much, Brio. That was a very fascinating image you leave us with. I'm going to close this block of the webinar. I think that yeah, we've been really going through the scales with Antoine showing us the territorial analysis and intervention on the basis of soil quality, quantity, and performance. And Alain taking us into also the design process with that, and Brio now closing up how really from the soil scientist part you can contribute to this. So I'm really happy. I hope that we can catch up time elsewhere. Sorry about that. And I'm giving back the floor to Anna, I guess.
No. I can take the floor because I will moderate the next session on methodologies to assess soil health in practice. I'm Lu Repelde from Naker in the Basque Country, Spain, and we will have 3 talks in this block. Please, again, post your questions in the chat, and we will try to have 5 minutes of questions in the end, but I think we are a little bit late. So let's start with the first talk, who will be given by Amanda Matson, Senior Scientist in Wageningen Environmental Research. And her talk is entitled An Index for Assessing Urban Soil Health in Amsterdam. Please, Amanda. We can see the presentation, but I haven't heard you yet, Amanda.
Exactly. You couldn't hear me because I forgot to unmute myself before I went to presentation mode. Sorry about that. And good morning, everyone.
Good morning.
Okay, so just stop me if you can't see, but I'm assuming you can now see the presentation and hear me.
Yeah, but not in full presentation mode. If you can put it in full mode, maybe it's better.
Oh, I am in presentation mode on my screen, so that's unfortunate.
Well, it's okay. I think we can see it.
No, you definitely don't want that. All right, I'm just going to stop sharing and reshare, and hopefully that will solve the problem.
Okay.
Apologies for that. Okay, so let's share the screen again. And hopefully this will work this time. If not, we'll just go through it in slightly awkward mode. Okay, can you see something?
Again, the same thing.
In notes mode or?
Yeah, it's not in full screen mode.
Oh, that's unfortunate. Okay, well, because we're behind time, I'm just going to go ahead with it as it is, as long as you can more or less see what I'm showing you.
Yeah.
So what I wanted to share with you today was an index that myself and my colleagues from Wageningen Research have been developing for assessing urban soil health in Amsterdam. And this was, and now I can't switch slides either, so this is really awkward. There we go. This was done in cooperation with the Municipality of Amsterdam and the Department for the Environment, who in fact came to us with this idea and had done a lot of work already in preparing for it. So when they came to us and we started collaborating, they had already developed what we referred to as a framework definition for healthy soil in Amsterdam, which identified a number of land uses of interest. So event terrains, city parks, neighborhood greens, gardens with and without food production, and sealed soils. And they had already also identified different soil functions and characteristics that they felt would be important in the urban environment.
I'm sorry, what they asked. we are seeing still the first slide. I don't know.
Oh, this is really unfortunate. Okay.
Amanda, I can take over
Yes.
if you want.
Please do. That would be great. Thank you.
Okay, you continue your talk and I will
Yeah,
take.
I will. Okay, so our goal then was to take what they had already started to develop and move on to the next step, which was, given this basic interest in these different land uses and soil functions, how could we actually measure that in reality? And so we attempted to come up with indicators, so things that could be measured in the field that we could use to understand urban soil health in these different land uses and in these different contexts. So if you go to the next slide. Yeah. So we had 4 main priorities. We really wanted this to be a pragmatic and useful system. So first, we were looking for relevant and informative soil indicators in the urban context. But also really important, we wanted to balance data quality and quantity with assessment costs. So doing soil testing is expensive, we recognize that. And while it would of course be ideal if we could measure every indicator of interest, that simply isn't feasible. So we really wanted to think pragmatically and ask ourselves the question, do we really need each individual indicator that we're interested in? Perhaps when do we need it, when don't we need it? And part of that was looking and saying, okay, can we recognize and include what the user already knows about their soils? Because of course, a land user, a land manager knows a lot about the areas that they're using and managing. And finally, then, collecting data is great, but how do you use that data to assess the need and the potential for change in a given area? So if we go to the next slide. The first priority then was this indicator selection. So how do we identify relevant and informative indicators for an urban context? And we started with a minimum set of indicators that had already been developed for the Netherlands in agricultural systems. And we used that to say, okay, which of these would then be relevant for the urban context, and made some slight changes, for example, with putting more focus on contaminants, less focus on productivity, and especially for Amsterdam, more focus on physical indicators, which are an issue specifically in that area. So next slide. Once we had our minimum set of indicators then, we tried to even be more selective and say, okay, all of these indicators could potentially be important in an urban context, but probably not in every situation. So we then separated our list of indicators by land use. And so that's what you can see here in this 2-tier system. Tier 1 was all around land use. Given the indicators we've selected, which ones are important in which land use? So don't worry that you can't read the picture on the screen. What you're seeing here is the A, B, C, D, E, F. Those are our different land uses. And you can see that there are different indicators that have been selected for different land uses. That's the take-home message of that part of the slide. And then the next part, after tier 1, so we've separated our indicators by what's important under different land uses, was what's important under different contexts. So if you go to the next slide. And this was where we tried to really take into account, what do people already know about their area? So what is the existing knowledge? But also, what are their specific interests and goals for this assessment? Why do they want to assess soil health? And can that help us choose which indicators may or may not be important in their context? So overall then, we have, if you click very slowly through the next bits of this slide, we have the tier 1, which is what indicators are necessary for a specific land use. We then add tier 2, which is what additional indicators might be necessary given your context, given your questions, given your knowledge. So that's the next bit if you keep clicking. And finally, that gives us our final list of recommended indicators for your question, for your context. And of course, it's understood in our index that you can ignore the recommendations. So this is not a regulatory instrument that we've created. If a user looks at the recommendations and says, well, no, I don't think those are necessary, but I do think this other thing is necessary, I mean, that's fine. So it's developed to be a very flexible system that really is reflecting what you need to understand about your soil. So if we go to the final, there we go. Now, another part, yeah, no, that's fine. Yeah, the field questions were, yeah, another part that we had developed in this system was an entire section around field sampling. So we addressed things like how to sample, where to sample, how many points to take. I do need the next slide. Yeah, thanks. What lab tests to use, or what do-it-yourself methods can you possibly use? So all of this is also part of the system we've created, which based on time, I won't get into detail about today. But assuming all of that has been done, then a user would have a collection of indicator data that they have brought together. And the final step is then to say, what does that mean? What does that tell you about your soil? So if we go to the next slide. So essentially what we actually have is an Excel sheet. So we're still a little bit basic in this index, but we have an Excel sheet that does then a scoring based on the indicators that have been measured. So you start here where you have your indicator data for your recommended indicators. And then what you need to understand what that means are a set of targets and thresholds. So what we've done is collect what is known so far about what is good. So if you click through this slide as well, you can just click through the whole slide and then I'll discuss it. We have brought together a number of targets and thresholds that basically are our current understanding of what is good for an urban soil. And based on those targets and thresholds, then indicators are scored based on, for example, some indicators you want more of, some you want less of. For some, there's an optimal range in the middle. So those scoring functions are taken into account. And then each indicator is given a score. And a user could then go through that scoring list, identify the ones that don't score well, and they're given options for improvement. Yeah, that's fine. You can go to that next slide. It's all good. And we have then a very extensive text that we have written, which for each of the indicators in our system gives a basic introduction. Why did we think that indicator was important? A little bit of information about where does the data come from that you have for that indicator, what we consider good or what science tells us at the moment we think is good for that indicator, and then management options. So should you want to make some changes specifically regarding that indicator, what is possible for you to do in an urban environment? And then we also have a very brief section on how those indicators relate to soil ecosystem services. So this is a project, as I said, we've been working on for a couple of years. We're hoping to have it publicly available by the end of February. So if anybody's interested, please do contact me and let me know. Otherwise, you can look at the end of February on the VER website and possibly through the Municipality of Amsterdam. I'm not sure how they intend to share it. And future steps that we would like are, of course, to do data collection and testing of the system to see how it works, to see where some tweaks might need to be made, and to expand the area of relevance. So this was specifically designed for Amsterdam, but there will be a lot of it that is actually widely applicable to other cities as well. So that's everything that I wanted to tell you today. Thank you for your attention. If you have questions, I would love to hear them, probably later though. And otherwise, do please feel free to contact me.
Thank you. Thank you so much, Amanda. Yeah, I would suggest that if you have questions, you can use the chat and we can continue with the next speaker, who is Cécile Leguern from BRGM, talking about integrating soil health and land planning in land planning documents, feedback from France. So Cécile.
Oh, hello, everybody. Do you hear me? Do you see me?
Yes.
Oh. So thanks for introducing this presentation. And so it's an example from France feedback. And so in France, as you may know, we have the climate and resilience law that was set up in 2021. And it's linked with the non-net land take objectives of Europe, but it also links neutral degradation objectives, what we call zero artificialisation net. So it's an extended non-net land take objectives. And in this law, we have soil preservation and restoration, which is a real aim. And there is, it's mandatory to revise the planning documents. But actually, taking soil into spatial planning is not so evident, as we've seen we deal with partial knowledge on soils, especially as we saw in the previous presentations. We usually have good knowledge or at the soil maps in rural areas, but we are missing knowledge on urban soils. So next slide, please. So in this frame, we developed the MUSE method, and actually to integrate soil in land planning documents, we based our thoughts on soil ecological functions. And actually, we developed 4 indices of soil functions linked. So the indices are water infiltration, carbon storage, agronomic value of soils, and biodiversity storage. So we developed a mapping method to map these indices with target issues linked so both to rural, peri-urban, and urban soils, with the aim of preserving agricultural, natural, and forest soils, as well as wetlands, with the aim of limiting soil degradation and maintain ecological continuities, and as well to optimize the use of urban soils and restore ecosystemic services. So this was a partnership, and I will explain more about it now. So next slide, please. So here's an example of what we did. So actually, we used soil and land data sets to assess soil ecological functions. We had 2 approaches. One is a direct approach using soil maps, so that exist for rural areas, not for urban areas. And the maps shown here are the examples of not urban area. And so in the direct approach, we used existing data on soil that are stored in databases, in national databases. And we could, using several parameters that are in the database known, we could calculate an agronomic value and the sensitivity to infiltration. So by using parameters such as soil texture, soil pH, and so. For carbon storage and biodiversity storage, actually, we didn't have so much data, but there are some national or regional statistics about linked to land use. And so we used the land use model to assess the carbon storage and the biodiversity storage. And then the method crosses these four indices to map the soil multifunctionality quality index, and using the soil map units as a referential. So this gives a quite global approach also of soil multifunctionality. I don't present the method developed for urban because it's just an approximation based on land use only. But this method was so let's see what we did out of this. So next slide, please. So maybe, so have you seen in the map before, we have some green areas with soil with high multifunctionality. So all the functions, the 4 ecological functions assessed being good, and those in red with no ecological functions, only bad ecological functions. And actually the MUSE method was assessed only on open soils, not on seed soils. So after this pre-operational tool, so where, for instance, the city of Nantes is using the map, soil map, to adapt its planning strategy, then so all the method is open source, and there is a link to get the method. And it's important to underline that it was co-built with 3 territories, so including the city of Nantes, the city more in a rural area of Châteauroux, and Aix-Marseille metropolis. And so it was, so it allowed to share the methods with other territories. And in the 3 last years, several tests of application of the methods occurred at different scale of planning documents. So especially in intermediate scale, schéma de cohérence territoriale, so at territorial scale, in urban territories for plans locaux d'urbanisme, so urban master plans, and also as well to design local projects. And in this frame, we did some methodological adaptations. I will present 2 examples of this, but before, just mention that the tool is now getting operational. We use national data sets, so we can automatize the GIS process and test it also with other data sets at lower scale. Nevertheless, the use of the method needs good engineering, GIS engineering capacity that can be internal in local authorities, but might need the support of engineering firms. And the final objective is to publish these maps with the national data sets in the national portal so that any local authority can use it. But of course, adaptation for with the adaptation of the methodology can be carried out internally. So next slide, please. So the first example of the application of the MUSE method and with adaptation was set up in Orangis, so within a program financially supported by the French Environmental Agency, which supported also the development of the MUSE method. And then the objectives was how to design an urban planning document that integrates the functional quality of soil with adaptation of producing new soil data to improve the local knowledge. So, and it was at the operational urbanism scale. So they developed, in addition to the soil multifunctionality map, so assessed thanks to the soil data map and characterization of the soils. They also produced a soil anthropization index, and so assessed both the densification potential and the renaturation potentials of soils thanks to this diagnosis, which they call agropedological diagnosis, and allowing to tell where soils need to be protected, where the design project needs to be changed to avoid soil loss, where it could be also adapted to reduce the impact on soil and where renaturation could occur.
I'm sorry, Cecile, try to finish soon.
Okay? Yeah, that's just one example in the conclusion. So I'm going to go quicker to the second example. So next slide, please. So the other example is on Red Metropolis and Pays de Rennes. So the objective is to integrate soil quality in planning scenarios for a quantitative approach of no-net land take, and the adaptation of the MUSE methods were carried out especially in the urban soil, where we used an existing method to assess soil infiltration capacity, integrating the VADOS zone. We could also assess biological and carbon storage, and as well as we extrapolated the agronomic value from the rural part, and we also integrated the silt surfaces. And also the soil map was downscaled to have a better knowledge, better precision on the knowledge. And in addition, we also mapped the soil pressure. So slide, please. And so the conclusion is that, the MUSE method was developed in the research project, is now used in operational projects. It's being used at different scales. Actually, the maps are quite easy to understand as reported by the user. Actually, we map rather soil ecological quality rather than soil health. And we're wondering how it would be replicable in other countries. And for soil health, we need knowledge more on the dynamic aspects, so the soil monitoring is needed. We also miss urban soil maps, and as we assessed also, we need minimum set of indicators to improve the knowledge on urban soils. So we've seen the work carried out by Amsterdam City, but we also developed aspects in the Supra project in France, and we also have so this is questions by the IndiquaSoil project, and also we have in the expectation also the soil monitoring. So thanks for your attention.
Thank you, Cecile. You have a question, I think, in the chat, if you can check it. But we will move to the next presentation by David Montagne from UMR Ecosys in Saclay about indicators of soil functions and soil quality. David.
Thank you, and good morning to everybody. So I will present you part of the main outputs of the INRAE study called Soil Quality Towards an Indicator System for Public Policy. Before starting, I will highlight that this study was based on two main choices. The first is to consider all land uses to deal with changes, to be able to deal with changes in land use, as well as the overall territorial monitoring. The second choice is in a focus on soil functions rather than on soil degradation as a motivational approach to describing soil health. So next slide, please. The first output of the study was a list of soil functions, each function being defined as an action, as for example, provide, regulate, store, or maintain, on an object that this object can be the water, nutrients, or the soil itself. We thus obtain 6 main functions, some of them being broken down into sub-functions from the most common pairs of actions and objects. So these functions are quite frequent, and so I won't detail it anymore. Next slide, please. The second output of the study is a list of about 50 soil indicators considered relevant for monitoring soil functions and soil threats based on their frequency of occurrence in the literature. If I focused on the top of this list, next slide, please. Next slide, please. The indicators are first matched with soil functions in two ways. Next slide, please. For a given indicator, the corresponding function is first identified. But you can use this table in the other way. Next slide, please. For example, if you want to assess the maintenance of the soil structure, you can see that this function is linked to two main indicators. Next slide, please. Here, the bulk density and the structural stability. But maintaining the soil structure is, sorry, next slide, please. But maintaining soil structure is also linked to some determinants or drivers, such as the particle size distribution, which is not an indicator, but which must be known in order to interpret the indicator values. The listed indicators are similarly matched with the 10 soil threats identified in the Soil Monitoring and Resilience Law. Finally, next slide, please. You can find information on the context in which the indicator have to be measured, as for example, at the soil profile or at the horizon scale, or whether it is used in economic evaluations. Next slide, please. The third results deal with the effectiveness or operationality of the listed indicator. The indicator operationality was assessed according to 5 main criteria, emphasizing the need for a technical operationality that is linked with scientific and methodological considerations, and a practical operationality linked to the suitability of the indicator to the issues at hand or to the ability of stakeholders to take ownership of the indicators. Next slide, please. Next slide, please. So among the 50 selected indicators, you can see on this operationality wheel that nearly half of the indicators can be considered mature or fully operational. This is the green part. When a quarter of this indicator are still maturing with incomplete standardization of methods, unconsolidated reference databases, or a use in the field that require support from experts. The last quarter is still under development, and among the indicators that are under development, most of them are metrics directly quantifying the performance of soil function rather than soil properties as the indicators that are mature. If we compare this operationality wheel with the French monitoring network of soil quality, it is possible to remark that, next slide please, sorry, that only 15 indicators are not currently measured, among which most of them are still under development, and that 16 indicators are currently measured, but only at certain locations of the French National Monitoring Network. Next slide, please. The last output of the study are references values for France that are needed to interpret the indicator value. The first type of reference values are existence values to evaluate soil quality. They summarized, next slide, please, by indicator, next slide, please, by land uses when they are available, the range of values observed in France. Thanks to the national monitoring network and to other national databases, such as SOILdraw, for example, existence values have been characterized for most of the 50 selected indicators. The next slide, please. The second type of reference values are threshold values. They correspond to the value of the indicator defining a degradation level or the value defining a targeted objective. In that sense, they are used to assess soil health. Next slide, please. Only a few threshold values and even fewer target values have been identified. Most of these values come from the soil monitoring and resilience law. The identification of tipping points around which soils are significantly degraded or improved remains then an open question. Next slide, please. Next slide, please. So, to conclude and to learn more about the study soil quality towards an indicator system for public policy, do not hesitate to visit the dedicated website on which you can already find or will very soon be able to find a range of media to suit your curiosity or the time you have available. Thank you very much for your attention.
Thank you, David. Very interesting talk.
Than noon. We would like to get a panel discussion with all the speakers of today, and we would like to open the floor to your questions. So we have prepared some questions, but I think now it's really the time to leave you the floor. So please, if you want to intervene, you can raise your hand and we can provide you with the floor. Is there any first question to what we have heard today? Does anybody has a burning question? Maybe you have already had some in the chat, some first exchanges, and it's time for you to go ahead. Maybe a first question as a starter from our side. I would like to ask our speakers, and maybe you can we can do it first for the first part of the speakers who intervene in the overarching view. Do you think that now we kind of have enough conceptual knowledge to implement soil health assessment? So are we really now being clear on what has to be done? And so if you think so, then what would be then the next step or the trigger to do it in practice? And if you think we are still missing conceptual knowledge, then what should we really wait for further knowledge to come in before starting doing any soil health assessment? So for that, I will just give the floor to Francia, maybe.
Yeah, well, thank you, Esther. I was about to leave because I have to do an exam for students.
Oh, okay. So
I can give my last. It's a good question. It's of course what we're also doing the SPADE project for somehow. But I think, as you see with all the presentations, that there is indeed already a lot of knowledge and approaches and experience to get it going. And coming from a planning perspective in urban design, time is something that you need. So if you see when new things are introduced in spatial planning and taken into, say, the practice of urban development and rural development, it takes time. I started my PhD around water, about the water integration, and I ended up in soil, because soil and water in the Netherlands is one thing. But if I see how long it has been taken and how much we're still working on getting it integrated, yeah, it's time that we really need and attention. And I think that, the projects that we saw today are excellent base. And it is about, that we, in the Netherlands, we have this soil and water steering, or we now have to say leading because of our politics. And what you see is that then the people in the planning and real estate, especially fields, are getting a bit upset because they're like, oh, that means that the soil person is in charge, right? And that is interesting because it's about people. Because, of course, I always say, no, it does not mean that the soil person is in charge, because the soil person also has to do other things that they're used to today. So if I look at, for example, very detailed soil analysis, which are super important, but in integrating, it's also about integrating in a certain resolution. So the resolution of data that can be integrated is of a say lower level of detail than you are maybe as a soil scientist used to doing in a very detailed analysis. So all these things I think is building up an experience, and I think today show that we're on a good path as far as I'm concerned. Yes. So thank you for the question. Thank you all. Great to see you.
Thank you for joining.
Bye bye.
Thank you. Bye bye. Yeah. Maybe also Antoine, what is your idea about should we are we having enough knowledge now, or if yes, then okay, we can move on, or no, we should.
I would say in a nutshell, yes, definitely, or no, definitely not. We don't have enough knowledge yet. There are two different sort of knowledge. The soil data, soil information on local situation, and then there is also in terms of knowledge, more systematic understanding of our agency and soils agency on urban planning. And this is also something we need to develop more and integrate into the different training and curriculum of designers and planners, etc. Producing knowledge and then integrating it into practice is also the next challenge. Not only having knowledge, but making them transferable, homogenized, and then also now it's not only anymore because the first knowledge are coming now. It's also learning know-how on how to integrate knowledge into practice is, I think, the new frontier. Mm-hmm. And this is, what a lot of us are tackling now. We are not anymore in the situation I was when I started my PhD 10 years ago, in which we knew basically almost nothing about soils. So urban soils maps are appearing now.
Mm-hmm. So that's optimistic and more positive. That's good. Alain, maybe if you have some reflection on such kind of level of conceptual knowledge, is it there or not yet, and should we act or not without having everything at hand?
But I agree with Antoine. I think the knowledge from the project, the urban project, is very important. Like we have the experience from Rotterdam. I think it's very interesting. The Gentere, I don't know if it's a good pronunciation, is very, very interesting to have the urban design experience, to know what we have to need to have a better knowledge of the urban soil for the localization of the right place, the project. And for the moment, I think we haven't the tools to localize the project on the right place.
And so does that prevent to act? Or can we still act without having everything completed? That's
Yes,
always the question, because the knowledge, we will always need more knowledge, but then we should be acting as well. Otherwise, we are losing soils as well. But that's a tricky question.
Yes, and the relevant knowledge, of course, for the project.
Yeah, and then Brieux, going to the rural side, or maybe all different types of land use, not only urban soils. What is your view on that?
Yes, my impression is that knowledge is not the largest bottleneck. It's to build the complete puzzle on a very multidisciplinary field, making people work together on the different aspects dealing with soil health and properties. I think we have a lot already, a lot of referential. I think we had several presentations this morning that proved that it's possible to convert knowledge into practical tools. And so for me, the main challenges are development challenges rather than knowledge development, even if these tools need to be evolutive and will keep improving, I think, with time and knowledge development. This is my point.
Thank you. I see that there is one hand hanging on from Geoffroy Serré. Please go ahead and ask your question.
Thanks for giving me the floor. No, I wanted just to answer to your question, Esther, and to provide three answers. Maybe first, I think we have to be aware that the concept of soil health is very recent. You know, 10 years ago, it was all about soil quality. Then we moved to soil ecosystem services, now soil health. I think all these concepts are interesting, but we have to be aware that this is still, as Antoine mentioned, an ongoing and under construction concept, and we have to still work on creating index quality and so on. And maybe we would have to merge the different approaches. The second answer, and someone mentioned it in a chat, for sure we need soil agencies in all the EU countries, maybe even a European soil agency, not only a soil mission, to conduct soil survey everywhere, including in our cities. And my third comment is, you know, as a professor in soil science, we need more soil experts. And when I mean soil experts, I mean also with the French term or pedologist, people that are not only capable to analyze a soil sample, but to describe a soil profile and to understand that a soil is a complex ecosystem with soil horizons and so on, in order to describe and to transfer this knowledge to urban designers, to planners, and so on. That was it. Thanks.
Thank you, Geoffroy. Cécile, you want to come in?
Thanks. Just to contribute to the debate. So I think, yeah, we have some knowledge on soil, and we still can use it as we did in the Muse method to try and use the existing knowledge to provide something to be used for spatial planning and design, or spatial planning rather than design. But surely it's not enough. It's just a starting point that helps developing awareness on soil. But I truly agree with Geoffrey's remarks. And also, I just want to underline that there is knowledge on urban soil is progressing, but still there's lots of gaps still to be filled. We still have no real soil maps, as was shown. And as well, as underlined one of our colleagues, we begin to have some tools But at the moment, we have some separate tools, and we need to make sure they go in the same way. They can be
coherent,
be compared, to be mixed, to be updated and improved, I think. So there is still a long way, but
we do have something on the ground still to work with. Yeah. Thank you, Cécile. David, you want to also come in? Yeah, or I don't know. David, you had your hand?
Sorry, my microphone was off.
Okay.
So it's just to precise that if we look at the wheel of operationality I have shown you, in fact, we have two types of indicators that are now fully operational. We have what I can call classical indicators that are mostly chemical indicators. I don't know, pH or soil texture, for example. But we also have newly developed indicator, as for example, indicators linked to earthworms or to particular behavior of carbon. And these indicators are now fully operational because huge effort have been done in just recent periods for 5 to 10 years. So it's not because we don't have the knowledge now that it's not possible to acquire this knowledge. And as usual, there is always a question of willingness.
Yeah, that's for sure. And not only from the research side, but also from the policy side, which
Exactly.
is triggering the system, both in land planning and environment, of course. Margot, you want to add on some reflection?
Yes, Esther, thank you. I'd like to, also share my ideas. I agree with what David said, that, well, maybe what we have on data is not perfect yet, but there is a lot already which we can use. There are also all kinds of ideas which we can use, and we should also be creative and see what's been done elsewhere, maybe also in other fields. And where we can find combinations. What I think is important is that we also showcase what is going on at this moment. Like within this webinar, we showcase some really great ideas and methodologies which we have, and we should bring that further. For example, the examples of Amsterdam are really worthwhile for other cities, and you can already work with it and give examples what works and what doesn't, and then we can make steps. And what is also important is that we have to show that it's essential that we do this, that it's essential within our planning, rural or urban, that we look at the characteristics of the soil and water system. If we do not, we have to cope with enormous costs within a couple of years, but for future costs may be immense. So we have to show the economical aspects as well as that we go and look more into the soil knowledge. It's important that we show what are the societal and economical risks if we do not take into account the soil and water system within our planning system.
Mm-hmm. Thank you, Margot, for this call for awareness and action on the topic. I see Pierre Courtois, you have also some questions. Go ahead.
Okay, thanks. I don't know. It's just an example that I would like to give. I work for public services in Wallonia, as several persons here know it. And the example I would like to give is just that in Wallonia we had a map which was translated into kind of law 2 years ago for erosion, and it made a lot of problems with agricultures. With farmers, I mean, and I was integrated in a group that was built with private societies, big societies as beet, sugar beet, and so on, potatoes, and so on. And there is a letter that is now for the moment on the desk of the agricultural minister of Wallonia, made by this group. And what I would like to share with you is that it was said in that letter that there is a lot of parcels that were addressed as a big problem in terms of sensitivity, erosion sensitivity, that maybe could not. Sorry, my English is very old. The problem is that those parcels are not really a problem, because it was said that they are situated in land with a nobody, with no habitation. So no problem of erosion, because there is no inhabitant.
Yeah.
That's just an example of what we said. The problem is not the knowledge, it's not the bottleneck. The problem is the willing of doing something to protect soils that need it. That's all.
Thank you, Pierre. Indeed, sometimes there are other issues that just knowledge there, the willingness to recognize the problem, and also to take that's usual reflection when we talk about erosion. It is only a problem if it affects the people down the stream or down the parcel, whereas we are actually losing soils at the place we are right now. So this is indeed some awareness raising among some landowners or land managers, that they don't need to wait to react until there is somebody else which is impacted, and they don't realize they are actually impacted right now, but for maybe not an immediate term, but longer term.
Yeah,
So,
yes, and what is it's the farmers are the first victims of that, but they don't realize it.
Yes, some of them
they have
realize
process of soil, and they don't realize it.
So some of them still realize that and are changing some their views
Yes,
on the stuff.
yes, you're right.
Thank you, Pierre. Maybe I think we should be closing our discussion right now. I will invite Cécile maybe to share some slides to wrap up. I just want to remind you that there is a whiteboard, so if you have reflection afterwards, you can use it. You can write down any ideas you have, or even contact or mention some projects that you are aware of that would be of interest, and to make any linkages. So yeah, you are very welcome to use all those tools. And I leave you the word. Thank you, Cécile, for some wrap up and next steps.
Thank you, Esther. And it's time, to finish. And we just write some key takeaways from the whole discussion. And we discussed about data needs to assess soil health at appropriate scales, because we got information at large scale and at small scale. We have discussion on project design, how to assess soil health in project design, and how to integrate economic, social, and environmental issues. And finally, we discuss about policy synergy, how to integrate soil health in broader policies, such as environmental and urban planning, to achieve unique outcomes, how to integrate soil into policies, And it will be good to create a decision-making tools for administrative levels with an emphasis on local responsiveness. Then we encourage cooperation to harmonize diverse interests in soil management and land use. We can see today that we got some different indicators. We have different research in different countries, and it will good initiative to collaborate and to compare the whole methodology that we discussed this morning. And then it can be good to align data, tools, and policies in soil health to help the sustainable land use. Let's continue to work all together to value and to protect the soil as living resource. Then we propose you to join the next webinar. Next time, it will be the 4th of April. And we will discuss about how to assess soil health at urban project scale and how to integrate soil health when renewing urban areas and recycling brownfield. So I thank you very much for the whole presentation and for the discussion. And we are looking forward to talk and to go further and to see you again and for further collaboration and to speak more about soil health. Thank you.
Thank you, everybody. Thank you for the speakers to have joined us and have a happy meal now, almost.